Next. Texture. What do you mean by texture?
Maybe like glass, plastic, or what we touch and what we feel.
And what we like feel. If you like touch.
Feel or touch. Actually, remember children. So we are very much lucky that we are having all the sense organs neatly. God has designed very well designed. So every child is unique. It's having its own bloom, and they're having their own glow in the face, and they're very much this thing. They're based on the sense organ, their sensitivity, especially not even with the sense organs. We can the sense of brain also great in the humankind what God has designed. But there are what we can say, some people who lost their eyes and some sense organs, so they couldn't see. By the visual effect, we can say that what it is belongs to and how the things are arranged, and based on that we can happily enjoy by seeing all these things. But the people who is not having the visual effect, vision, blind, tell me children, by the sense of touch, by the order, by sound, audio, all these sense organs plays a major role. So easily they can go with the texture.
Yes, ma'am. When you touch like a cloth, so ma'am, then you have a different feeling in your hand, and if you touch something hard, then you'll have a different feeling in your hand. So then we can sort it into groups based on the texture.
Even we can understand from the sandpaper. If we touch it, it will be rough, and if we touch a soft cord or something like a cloth, it will be so soft.
Yeah, very good. So by that texture, we can easily sort out the things to which it belongs to. Okay, especially sometimes while it's in a playful time when we go with and tie our eyes and we go and feel the touch. Especially when your parents will give you the surprise. What they'll do, they just cover your eyes. Okay, and they ask you to touch and say the thing what it is. Yes? Yes or no?
Yeah.
Yes, we need to integrate the subject with our daily things around us, especially what things around us we need to integrate with the subject. Then only you can understand. I'm not getting any examples from outside or somewhere or any other thing. To make you to feel and understand the concept, I'm giving you the easy examples so that by observing it, you can understand.
Yes, ma'am. We are able to relate to it better like that.
Yeah, we have to. We have to not only the science, every subject, we need to correlate with the corresponding things, especially when you go with the social studies, definitely you need to go with the current effects. Not only sticking to that years and dates, whatever present in the textbook, you need to go with the present scenario so that you can understand the concept much more better. You can analyze the concept. Yes, if you observe the texture, in this, especially the texture, you can see that by the feel of touch. Yeah, dear, Neha.
I was just asking, can you hear me? Because you could not hear me.
You could not? Sorry, pardon?
You could not hear me.
Yeah, my voice is low.
No. I thought you could not hear me. That's what I...
No. Yeah. Okay, so these are the different materials for the feel of touch we can easily. What is the first criteria we have dealt with?
Appearance.
Appearance, and the next?
Texture.
Luster and texture. So by the texture itself, we can come to know that the materials which are made from wood are sorted into one separate group. the materials which made from metal are sorted into one separate group. Understood? The materials which made up of plastic can be sorted into separate groups. Okay.
Yes, ma'am, it's an example like our garbage.
Can I give you the best example? One more example. Can I?
Yeah, ma'am.
Can I give you the best example?
Ma'am.
Especially when we order the things in the online. Okay. So by the visual image, we can definitely get the things by seeing it, and we'll order it. Like especially the textile or whatever it is.
Yeah, ma'am, but when I ordered one cake by seeing it exists, but they fooled us. It wasn't looking like when we ordered it, it was looking something else.
Yes, really. So especially when your mother ordered a beautiful sari, a best model, like what we can say that the sari outfit and everything is excellent. Your mother was having a much more expectations by seeing it. And when your mother ordered, when you got back the delivery, what do you feel after touching the texture of the material?
Ma'am, like exactly
We
same.
will look it as leather or no. Leather, cotton, silk.
Yeah, but he with the much description that it's a blend of cotton or somewhat like that. It's a shiny material. But after coming, if you feel the touch and texture, if you see the texture of the material, the description is right. But you don't know exactly what material it is. Okay, when you feel the touch like texture, then you can say that it's a low quality material. It's made up of, it's not a complete blend. It's a less pure in quality. Definitely what you'll do, you'll return back the thing. Okay, the best example nowadays we are going with online. This is the thing happening in every, most of the orders. If the order is reached to our expectation, well and good. If not, but the texture itself will come to know that it doesn't belongs to pure, it's an impure and it's a complete imitation of a pure. Yes or no?
Yes, ma'am.
In that sense also, the sorting things into materials helps a lot.
Last day I bought one thing and they delivered another thing.
So this is the thing happens. Our appearance will give the separate image effect, and when we feel the touch, definitely we sort out the things whether it is belongs to that particular standard or not. Yes or no?
Yes, ma'am.
Next. So today we are mostly going to wind up this sorting materials into groups, and we are going to discuss few questions. And what about the online exams, this weekend exam? How did you attend it?
Ma'am, I attended.
Yeah,
Ma'am, I was unable to because I was out of town.
Yeah, Pragya, what about you, dear? Pragya? Ridhima? Pragya and Ridhima? And what about the questions?
Ma'am, I just got only one wrong in chemistry.
Yeah, I think I have given like not completely based on, it's like quite what I mean to say, reasoning type thinking, hot like a hot
Yeah,
question.
ma'am. You asked one question that why are these balloons tires all made up of rubber?
Then you should go with the properties like flexibility and elasticity, all this.
Yeah.
Like mostly like a hot question type I have given so that you'll think and write the answer.
Ma'am, in that there is appearance also and also texture, I think so, in that question. What you have given.
But actually in the last session itself we have completed appearance and all. Just going with recap, that's why I have included those concepts. Otherwise,
Yeah, ma'am, even we have completed till solubility.
yeah, till solubility we have completed. Good. So state. That's what today we are going to wind up mostly almost all the properties we have done because of the gap we got, so we couldn't. So we are going to complete it in this session, and we are going to discuss few questions based on that.
Ma'am, nowadays I'm having examination actually.
Oh, good. Next, states. In the states, we'll be having molecules of solids, liquids and gases. So molecules in solids, molecules in liquids and gases based upon the states. This is very, very, very important. Why I'm saying it's very important in the sense, this concept is very much helpful till your standard 10.
Ma'am, I have started learning this from my second standard.
Yeah, but it's very important. Even standard 10 questions also based on this. You'll feel that it's very easy, but based on many other concepts also including with it. Okay, states like solids, liquids and gases. Molecules in solids, especially if you go with the solids, all these molecules are very much compactly packed without any gap. That's why it is considered a solid. When we see in the liquid, especially, the force of attraction between the molecules are quite less when we compare with solids. Understood? The same way when we compare with gases,
It is very, very less than the solid.
very less, very, very less. They are not, they need to be forcefully attract with the other molecule. Otherwise, they are bit far from each other. They are bit far from each other. Okay, based upon.
I want to ask this. Like a plastic box or container is a solid thing. Does it it just consists of only plastic molecules? Is it something like that? I don't know currently.
Yeah, definitely. It's a polymer. Plastic in the sense it's a polymer. It consists of only carbon, hydrogen, some other molecules or some other atoms combined, and it is having some different properties. But it comes under solids. Only we are sorting the things whether it is metal, plastic or non-metal, nothing else. We are only discussing.
In that also it will be like these molecules will be tracked like you have given in the figure, right?
Yeah, definitely. Any solid, that's what I'm saying. Na? Any solid, whether it is wood or whether it is what I mean to like metal or whatever, the particles are arranged very closely. They are not compressible. Okay, for example, here it's like a mobile is there, so it's also a solid, and this is also a solid. These two are two different things. But if I give the criteria classification based on state, these two belongs to?
And that belongs to solid.
Solids.
Solid.
Yeah, here for the classification, main criteria is state. Especially particularly in this slide, state, solids, all solids, the particles are very tightly packed. When we discuss about the liquids,
if they won't,
quietly, 1 minute, let me complete this concept so that I'll give time to ask you the questions. Pardon?
Okay, ma'am.
Yeah, thank you. So in this liquids, all these particles are bit far from each other when we compare with solids. And if you have seen the gases, they are much more far than the liquids. But one more thing you should remember that, children, solids are having least kinetic energy. What do you mean by kinetic energy?
ma'am, movement.
Energy is obtained by the movement of the particles.
Yes, ma'am, I know why.
In case of solids, the particle, the force of attraction is very much tightly packed. Okay, like two particles are there. For example, here two particles are there. These two particles tends to come closer, so that the force of attraction from both these molecules, they are close to each other. Understood? That's why they are tightly packed. And there is no formation of new energy takes place because doesn't have any kinetic energy. In case of liquids, liquid consists of kinetic energy because of the less force of attraction when we compare with solids, they'll move and they'll strike to the walls of the container. And even they strike to its own molecules. They'll strike its own molecules. That's why if you have taken a plain water or even in the tumbler, the water is not stable. The water molecules are quite movable. Have you observed any time?
Yeah, ma'am. Can I give an example?
Yeah, sure.
If I would take a container and put it like upside down, it won't fall down if I catch it. But in the case of water, I take water in a container. If I keep it upside down, it will fall down.
Yes, you can, because of the kinetic energy of the particles present in water. Understood?
Yes,
So in case of molecules in gases especially, these molecules have much more kinetic energy than liquids. The best example can I give, children?
Ma'am, before that, can I please say something before that or after that, ma'am?
Yeah, dear.
Ma'am, I know why they have less kinetic energy, ma'am, because solids do not they have no movement, but liquids, they still flow, so they do still have movement. And gases, since the molecules are very loosely packed, so it keeps, moving around. So that's why it has the most kinetic energy.
For sure. And here, molecules in gases especially, these gaseous particles, I'll give one example that if I take an unlit incense stick in one corner of the room. So if I want that order especially, I need to go near to it, I need to hold it, and then only I can get an order. Because it is an unlit incense stick. Yes or no? When I lit the incense stick, if I very much far from it, or if the incense stick, lighted incense stick is in this particular room, if I go to the one separate room, even though I'll get a nice aroma of it. How? Because when we give the heat energy, the gaseous molecules itself, it is having some kinetic energy. When you give the heat energy, what happens? They'll take this heat energy so that they'll move much far from the normal kinetic energy, within its normal kinetic energy. And these gaseous particles will strike from each other. So here this is incense molecule. So when it comes and strike to the other one, and this will move with a great force, so that this particle will go and collide or strike to the other one, so that this nice aroma will pass from one corner of the room to the other corner of the room. Have you understood?
No, ma'am, I didn't understand about the gas.
Yeah, I'll give you the best and better example so that you'll feel that wow. Okay, let me?
Yeah, ma'am.
If when you return from the school, you'll be near the gate. But your mother at that particular time, your mother is cooking some nice and neat dish and you are very much hungry at that time. How can you know that your mother is cooking one particular dish?
By aroma.
Yes, how it transfers, how it flows.
By
let me. The same dish, what your mother has cooked, the same dish, take out from the refrigerator and place it. Is that the aroma is cooking one is much far having kinetic energy?
What were you saying? Taking out from the refrigerator, I could not hear.
It's nothing but when your mother is cooking some dish in fresh, so that the aroma will pass from one corner to the other corner of the even to the street level. Am I right? Because while your mother is cooking, what happened? From the heat, this gas forms from the dish. With the heat, they'll attain more kinetic energy. They'll strike with each other and they'll move more far. Much more far.
Ma'am, then what happens to the frozen food?
Frozen food is nothing but the kinetic energy is low. They can't move much faster than this hot food. Am I right?
Okay, ma'am. That's why when we make hot food, there is some vapors forming.
Yes, definitely. Take the vanilla milk, hot vanilla milk, and take vanilla ice cream. Which one you feel that vanilla is present? Until and unless you taste the ice cream, you can't know that it's the flavor. But when you take the hot vanilla milk, definitely you'll feel that okay, vanilla essence is there.
Yes, ma'am, because of the air molecules, I mean the gas molecules.
Yes, because there the gas molecules plays a major role, and the kinetic energy also plays a major role. That's why there is some differentiation with the solid, liquid, and gas. I think these examples are quite easy to you all.
Yeah, ma'am, the examples are quite easy.
Understood?
Yeah, ma'am, understood.
Yeah. So you can sort out the things based upon the arrangement of the molecules, whether they are solids, liquids, and gases. Solids, liquids, and gases based on the arrangement. Not even that we can't consider that it's a solid or liquid or gas, whether it's metal or non-metal. Here we are only given the criteria based on the arrangement of molecules. No one can come here and say that okay, it's a solid. You itself come to know that whether it's solid, liquid, and gas, and you know the mass, and you can imagine the mass. Yes or no? Take the container, empty container, lift it. You'll feel it's very light. The container containing liquid, it is much heavier, so that you can imagine it. Understood?
Yeah.
Yeah.